trip hazards. Good evening, everyone. Thank you for coming. And very pleased to welcome Keb Garavito from Pilbara and Partners. He's going to talk about, I was going to say the edge. It's not, you drop these. It's just edge, London Bridge. And which is in a good state of construction at the moment. So go and have a look after the lecture because it's not finished. So it's a nice point to. So thank you for talking about it during the process. And also it's nice to go and look at stuff that's being built. And you pointed out just beforehand this building, AHMM apparently, it didn't get planning permission, so that doesn't exist yet. But thank you very much for coming in to talk about an in-progress project with such high kind of sustainability kind of ambitions. And so thank you. Great.
Thanks for having me. So I'd like to take you through Edge London Bridge. This will be, it's named, the developer is Edge Technology, so it's a Dutch-based developer. And this will be the first of several buildings in London, but it's one of many that they've built around the world. And their goal is to always build, as in their own framework, better buildings, so better than the one that they had built before. And they look at it across a spectrum of parameters. So what I'd like to take you through is some of the early work and then get into the current state of the project today. So we're situated just south of London Bridge Station. The Grimshaw's new entrance is opposite our site on St. Thomas Street, just a little bit east of the Shard. And the ambitions of the project in sustainability and well-being are something that architects are quite used to talking about, and they have done for a very long time. But there's been a lot of development in how we make that discussion a bit more precise and a bit more broad as well. So I think we're all used to the data that's coming through in terms of global warming, the implications, which for the longest time, that's what global warming meant. It meant something that was happening over there. Increasingly, we're seeing what's happening over there is starting to happen over here, but it remains a subtle and, to some people, a subjective appraisal, and a lot of it is still happening over there. What I think for the last, since I've been working since the early 90s, there has been a discussion around sustainability. It has always been part of how we're trained and how we work. But the terms and the scope of how we look at it was principally directed at the fabric of the building itself. And a lot of work has been done more recently to say, what does that mean in terms of how we assess sustainability across its construction, demolition, use, and rebuilding. And I bring up this slide because I think there is increasingly in the last 5 to 10 years, there's still a sense of we've done a really good job in the West. Why do we need to go any further when China is still going to be chugging out tons of carbon? But if you look at the graphs, the growth is starting to happen in other parts of the world, but you can see about less than 20% of the world's population is producing half of the world's carbon emissions. So it's quite a shocking element consideration. And then the other thing, which I'm sure all of you are quite familiar with, is the burden that's placed on the construction industry itself and how that's subdivided. So about 40% of all emissions are due to the construction industry, and about 20% of that is, half of that is to do with the operation of buildings, and half of it to do with the construction and materials that go into it. But the other side of the question is buildings themselves. So when that discussion, which to some extent was a specialized assessment of building fabric and optimization of the fabric, left out the occupants of the building and the impact of the building on the city that it's within. And it's particularly critical since this stat of Europeans spending 90% of their time, in fact, it's replicated across most of the developed world. The issue with it is that too many of the buildings that we spend our time in are not good for our health. They have poor characteristics, and they're expensive to run. They have poor air quality, and that leads to consequences, particularly in working environments, of disengagement and poor performance. So maybe reaching in this direction as well, we might see what opportunities a new standard of building might set. So our site, as I mentioned, is actually in a hugely diverse and varied quarter of London, around London Bridge Station. It's blessed with a rich historic fabric, as well as new buildings from the Shard, the station infrastructure, which has been enhanced quite recently, and a number of changing uses. So our site itself, we're halfway between, let's say, the Shard and the cluster of buildings that's developing there, and Bermondsey Street, which I'm sure you all know as a rich neighborhood. Nevertheless, this is the site that we inherited. It was a Home Office detention center. The structure was, as you see it there, it's on the outside of the building. It's a very difficult building to reuse, and most of the site was defensive, secure, and in terms of its generous relationship to the streets around, it was not doing such a good job. So maybe there was something missing that we might explore in bringing something that's a bit more diverse and that is tied in, maybe both physically and metaphorically, into its environment. This is a painting that was done from our site. So this was in the 16th century. You can see the Tower of London in the distance, and this might suggest a form of landscape and a social and commercial architecture which is tied to landscape and buildings. And we might, on top of this, layer on a lot of the specifics that are requirements of current office occupation. We were appointed in 2018, so it's been quite a long journey. And prior to us, there was this scheme that was going through planning with Southwark. And it was a bar building that was set to the north of the site, basically fattening up the bar that existed on the site, with a tower that was cantilevered over to the south, and there was a slender garden space which was on the south side. That slender garden space was poorly lit because it was tight up against the buildings immediately to the south. And we thought perhaps there's something in revisiting this approach, and to look at something that would provide something which offered a connection and a visual identity to the site. So a new public garden that is situated between the station and provides a setting to the church, which is immediately to the south, but also introduce diagonal routes across the site in both directions. The figures on the left, there was a pre-existing development framework that was developed between Southwark and the landowners on the 4 adjacent sites. And there were a lot of good principles that were established in that, but they were stymied by the previous proposals for the site, in that it offered a barrier, even though there was a suggestion of this being an important entry point to a network of fine-grained streets on the site. So our assessment suggested linkage across to the east. That produces a larger garden. We sit on less than half of all of the land at grade, and we offer space which is better lit, The repositioning of the building improved wind conditions on St. Thomas Street, and tried to bring active edges to all faces and all corners of the building. Having said that, the design of once we decided to move into this organization and position on the site, we started with a diagram which isn't far from where we've ended up, but a core disposed to the east of the site, opening up a floor plate to the west, and with a flexible zone, in this case, in our original scheme, on the western half of the site. So a soft zone that would allow for interconnection between floor plates. The arrangement is allows that at garden level, the building can set in. Typically, a center core would stymie that operation. You'd be required to maintain depths across the floor plate. So the idea that this landscape could connect in literally and visually into the ground floor, and that the ground floor is a public space. So it's not a corporate interior not to be entered into, but one where the doors are left open so that the public is invited in to use the space. So the primary elements, the core, the primary workspace, and what eventually morphed into the play zone, went on a journey of reconfiguring on the site and optimizing here closer to what we eventually ended up with an organization at the base of the building, which is a 4-story podium level, which is also open to the public, with some of the facilities in those levels available to local community groups and schools and local businesses. So that principal organization. And then I thought, it's a bit of an indulgence, but I thought I'd show you our first stab at the building in terms of its envelope and its organization. So the core set there, an external environmental screen, shielding from the sun, and then a splitting of the north elevation into 2 elements of a plan of distinct character, so that you ended up with a slender gable, and then this west facade, which is shielded from the sun through vertical shade, and the south in its own fashion. So quickly going through these, and then opening up space to the lower ground. So more moving on from that, we started working with our landscape architect, CTF, and looking at how much we could integrate this idea of landscape extending into the base of the building. And that was to allow something that was visually coherent across the spaces, but also one where the idea of a landscape would actually travel up the height of the building. And by that, I mean synthetically, so to allow for, rather than a tower building as a set of pancakes which are stacked on top of each other, to allow one zone of the floor plate to be a soft zone that would allow floors to interconnect between them, and to be flexible in the way that they interconnected. How do we get here when we're trying to look across a number of parameters? This is some of the analysis that we have in-house, but it isn't something that you can do in isolation. So almost all of our partner consultants have the equivalent of this, and it's really important that we're able to share back and forth and to break away from a stratified form of communication in the earlier stages of design, so that we're looking at across wind, light, energy performance, and the embodied carbon in the fabric from the earliest stages. Within the fabric of the building, there's a number of principles. So in this case, looking at water management across the site. There is no, on most large facilities, there's a large attenuation tank which is housed in the basement. Here the attenuation is through blue roofs across the height of the building and on the ground floor. A view of the base of the building as it will come through. So the planting, providing not only an arrangement with routes across the site, but also spaces of refuge. The facility that you see cantilevering out at first and second floor is the town hall space, which is, I mentioned earlier, is available to local groups. The arrangement of the building sets in at the north and the south so that we have a portico entrance and a second garden space, which is arranged at the southern end, where there are already active frontages to the south and to the east. The building also relies on mobility, sustainable mobility infrastructure. We have 600 cycle parking spaces at the base of the building, but the strategy internally is also to encourage all vertical movement through light. So the staircases, including the fire escapes, are daylit. Rather than having escalators leading you up to the first floor, which is the upper level of the deck system that we're using for the lifts, it's a set of steps that take you up there. The selection of the lifts is a twin lift system. The twin lifts, you may be familiar with the double deck. You may also be familiar with this, but there's one manufacturer which it's effectively two independent cars which move independently in each shaft. It has benefits in being less energy intensive because it's more efficient in moving people around the building. And because it is more efficient, it means you require fewer lift shafts. And because you require fewer lift shafts, you can have a smaller core, so you're reliant on less concrete for that element. The building is built using a top-down construction. So I've tried to speed this up so it doesn't take too long, but top-down construction in London, I think it started to be known when at the time of the Shard was built. So it's to say that the ground-bearing slab is built and excavation happens at the same time as you start to build the core up. In this case, the limitation was, I think it was 20 stories on the core and 19 stories on the rest of the floor plate was the limitation in terms of timing to complete the basement. So the sequencing as it's going up, and you can see that the primary elements, concrete frame with a concrete core, and then the hybrid steel and timber frame for the play zone, which in construction terms is lagging behind. So at lower ground, there's one level of office space, which is naturally lit by skylights, which are set into the gardens, as well as through two sunken atria. The sunken atria also provide air to the air in and air out to the plant at levels B3 and B4. And the cycles are accessed. There is a lift, but there's a very gently sloping cycle stair, which leads you down to a gym, cycle storage, and changing facilities. At the south end, on the ground floor, is a cafe which opens up and animates that corner of the building. The southeast corner is the goods inn. You'll notice that we don't have an internal loading bay, so it relies on consolidated offsite servicing, which means that you minimize the number of vehicle movements to the site, again, reducing carbon emissions locally. And you have two lay-bys on the east side of the site that allow for vehicle deliveries. The delivery bay is split so that you have a sort of dirty entry to the north, adjacent the goods lift, and then there's for mail deliveries and lighter deliveries, a more public-facing lift. So here are some photographs of the building as it was. These were taken about 3 weeks ago. And the organization at the base is hybrid timber with glulam set into the structure. So glulam and CLT into a steel frame supported off of the concrete columns. The organization of the town hall. And here we wanted to use principles of off-site manufacture for efficiency, but we also relied on a lot of experience from others in the industry. And very early on, we went to see the Google building, which was fascinating but also worrying at the time. So we went in, I think it was 2021, prior to going into contract, and you could already see that all the CLT was stained from water ingress. Basically, the construction had been slowed down over the pandemic. The structure had been left to be exposed. There was a lot of water ponding, and that leached into the timber. The consequences of which is, even today, they're having to go back in and rebuild, remove elements of the timber and put it back in at, I'm sure, vast expense. But they do have some money, I think. So how did we get around it? There's a few things that we had to consider with the timber. So one, you won't see it in this image, but we introduced drainage into each of the panels. So there's a drilled hole and there's a temporary drainage system so that during construction you don't have ponding, and anything that does come through doesn't just wash through the building but is taken away. And we also have a waterproof topper on top of that so that it also doesn't get saturated into the timber itself. And then the third element that we had to deal with was the fireproofing. And there's a lot of development in the work where you're doing all timber buildings, or where you have very clear separation of materials. And in our building, where our construction sandwich is very tight, so our typical floor-to-floor is 3.74, which for an office is quite tight in London. And on top of that, we wanted to generate good, clear height. But you can see, because the glulam beams and the CLT, they sit within the depth of the steel, you have an issue that where normally you rely on the charring of the surface of the timber to protect the timber, when the steel itself will have an intumescent coating to protect it in case of fire as well, so that they independently provide the resilience. However, when the steel doesn't have the room for expansion because the timber is in bearing and in contact with it, you have the issue that the steel heats up and starts to burn the timber further back, so it compromises the structure overall. So if you look carefully, you can see we had to introduce isolation bearings wherever there was that interface. So it's a very simple adaptation, but it introduced a new level of complexity to the structure. Higher up the building, you can see the floor plate is organized. So the play zone, which is across that area, so that's the timber framed element, concrete framed on this side, and then the core is arranged so that you have a central lobby with views out to light in both directions. It allows you to always know where you're positioned in the building, in the city, but it also allows for a subdivision if you're going to have dual tenancy on the floor plate. I should probably point out, because this is a very old plan, we originally had a scissor stair, and we had a very beautiful design for it, but that was also one of the elements that needed to be modified in discussion with the fire brigade. There was concerns about how they would access the building in this kind of arrangement. So the timber zones, they're arranged at the base of the building and in the play zone. There's a slight variation, so you'll see that at the base of the building we're using a glulam beam with CLT, and there's a concrete topper, and that's required in order to stabilize the frame and those floors and link them back to the core. Whereas on the upper levels of the building, when we get into the play zone, the design was always to allow for that interconnection, so it's all dry construction. So the timber has a gypsum topper that can be removed, and that allows for the floors to interconnect, and they're all small panels, so it's easy to lift these elements out and remove them. So that that level of interconnection, and you can open up to 4 stories of floors. You can, in fact, you can interconnect all floors if you wanted, but you'd have to do a fire enclosure every 4th floor. And the reason for that is the primary structural frame, because the core is situated to the southeast of the site, you have an eccentric movement, and so a northern brace frame is situated to the north, and every 4th floor, that brace frame has a connection, so there's a connection back to the core, so it's essential for the stability of the building. So operational energy, a number of factors going into the assessment. One, looking at whether the building could be a breathable building, so we have opening elements of the facade, but the air systems for the building are high volume air, but distributed at a tempered level, but not it's not a full displacement system. So you have locally, the air is distributed in the floor. At ceiling level, you have climate islands, which locally temper it, and they're controllable. And the other part of reducing the energy consumption is ensuring that there's sensor distribution, and that allows for the building to be responsive to use and occupation, but also to inform tenants how they're using their spaces. So a number of criteria that are used in that assessment. And then one aspect of the health and well-being is the sense of connection not only at the ground floor to outdoor space, but throughout the height of the building, and at the top of the building there's a tenant club space, which is accessible for all. In terms of the palette and the inspiration that we took, rather than a brand new shiny building, which to some extent it will be, we were interested in an expression of the material, so that when you see the concrete is cast in situ, even in the northern braced frame. The terracotta, which forms part of the western brise soleil, is variegated in its color, and it changes quite dramatically throughout the day. On the south elevation, the building organization presents a narrow facade, so it minimizes heat gains, but we also introduce a brise soleil here with photovoltaic set on the horizontal and vertical fins to assist with lateral light as it's coming in. And then the northern brace frame that I'd mentioned before, which is organized with spun sections in order to minimize when you're looking out from the inside of the building, that you have a sense of looking through a window, a bit like a Georgian window, and in its own way inspired by some of the very beautiful work that Oljati has done. I should have mentioned the diagonals are steel, so they're single elements of steel. You could see in the upper right-hand corner, it was originally designed with a jointed connection, and we moved away from that assembly so that the connection is hidden within the concrete, and it means it's more robust and it doesn't need to be maintained and viewed regularly. One key element, when we submitted for planning, the building had very low embodied carbon for a building of its nature. In fact, compared to, let's say, in London, we did a retrofit at 127 Kensington High Street. This is lower embodied carbon than that, and it's new structure. And there's a number of ways that we managed to get to that point. But more remarkable still, the building is the first that we know of in the UK and possibly in the world, where the embodied carbon and operational carbon was set into the contract terms with the contractor. And it has been an incredible journey, because we've managed to bring down the 860 to sub 600 by a number of means, and it's meant a lot of redesign along the way. There's been a lot of optimization of elements throughout the fabric of the building, but the operation, but the building's performance as well. So the target, so we're Paris-proof. In terms of This is maybe for a more commercial audience, but in terms of the targets that we're meeting, BREEAM, you'll know, is the sort of old-style way of assessing. I mean, it is the current way that you assess sustainability, principally in the fabric of the building, well in how the building is occupied. Neighbours is relatively new, an Australian assessment with its own British variant, but which is looking at the operational energy specifically in use. So this is a target, and it is yet to be tested. And then wide score relates to its connection. Yeah. I wanted to bring this up because along with the building having objectives of its own in terms of its construction and its aims for the performance of those who are going to live in the building, it is also a test bed for improving future construction. So this was an investment by AKT, Edge, and Mace. So it's not something that as architects we contributed to, but I think it's a very unusual thing. So there's quite an expensive thing to insert sensors into all the foundations, and there's been a testing regime to establish the performance of the pile-assisted slab foundations. And why this is important is because there is no test data on how this construction type is created. It is based on theoretical models, and therefore it is necessarily needing to be conservative in its assessment. So they have managed, and they have the first round of data has come through, so that when they next build a building, they'll be hopefully they'll be able to use less concrete in the foundations because they understand more the stress and strain which is happening in those columns. And then lastly, I thought I'd leave you with a few more photographs. So this from street level. So if you did want to come to site and have a look, you can actually see quite a lot of what's going on from the street. This is a view along St. Thomas Street, across tracks. Further views of the interior, and then a view looking across the node prior to the installation of the glazing. So I think that's it, and I hope I haven't made that too compressed.
Thank you. Thank you very much. Could you take some questions?
Yeah, absolutely.
Fascinating. And I'm guessing that along the way you're doing kind of environmental analysis that enables you to make decisions as you go through the design process. To what extent do you do that in-house, and to what extent do you rely on external consultants to provide you with that data?
We do a lot of it in-house. So we do have in-house carbon assessment, which I think, in fact, increasingly architects are starting to have in-house. There's a few that have been leading the way in this. But we found early on when we set up our company in 2013, there was a way of going about designing buildings where architects would design a building and then hand it over to an environmental consultant or a daylight and sunlight consultant or a wind consultant. And it has two consequences. One, that it's quite an expensive way of working. There's a lot of redundancy in the work. And often you get to this point where, because the design program is quite compressed and the program to planning submission or construction is tight, that you'll do all of that work, and a lot of the assessment involves a lot of post-rationalization. How do we communicate this back so that it's acceptable to planners, or what minor tweaks can be done? And the more that you can bring in-house, and we started first with daylight and sunlight assessment because it's a really important criteria in the UK. It doesn't really exist elsewhere, but it meant that we could very quickly understand the implications of massing changes in our buildings to neighboring sites, as well as if we're doing residential, what it meant for the apartments that we're producing. And that's evolved. So I think we started to do then sunlight on ground to understand what the implications for the public realm was. We brought in wind analysis, very slow, but we've managed to get there. And if you provide enough time, you can get it going. And then solar irradiation on facades. And then interestingly on this project, Atelier 10, who are the services engineers and the sustainability engineers, they shared with us a facade tool that looked at a number of different metrics. So it was looking at the glass specification, the degree of shading, the degree of solid glazed ratios. And so having that as a set of tools that you're sharing across parties is really, really helpful. One, because it's ultimately how we all need to work to do what we hope is a good building. So if you can establish and bake in the principles of the design, I think you're doing a better job. And it's what architects, I think, have always done to some extent. It's only now we have more tools at our disposal to be more precise about how we assess all those things.
Thank you.
Any other questions?
So you mentioned how at the Google building they had like quite a surprise and a misstep because of COVID-19 and use of timber, right? So when it came to designing this project, is that always a part of the procedure now to like overthink like events that could possibly really affect the building's construction like that?
Yeah, I don't know if I would characterize it as overthinking. I think it's probably essential, and to some extent it's surprising that they didn't consider it, because it's an obvious thing that if you're working with timber, you don't particularly want to leave it exposed to the elements unless you're working with a particular timber which is, that you might use in marine environments or something like that. So I think, especially with stuff which is quite common knowledge, you do need to think ahead about all of that. And I think the stuff that we have done here will probably be baked into how things are done in future, because it's relatively simple. It is a little bit more expensive, but ultimately, if it means that you don't have to then come in and rip out loads of CLT after the building is complete, then you're doing yourself and the building occupants a service, I think.
Thank you.
Any more? Okay, very good. I have a question as well in a minute.
Hi, thank you so much. I have a question. Sorry, I hope I didn't miss it because I came in a bit late. I suppose about sustainability you just mentioned is a little bit more expensive. And how was it defined by the brief, initially in the brief by the client that you want to do really high sustainability? Or I just hear a lot that it's often quite greenwashed, and then when it comes to construction, clients fall over because they want to save costs. And I suppose it's still often a little bit more expensive or more expensive. My question is, how did you convince the client, or was the client from the beginning on board?
I think the client, their raison d'être is to do buildings that are lower and lower carbon and that work better. So that is where they come from. And I think from a commercial perspective, I think there's an ethical side to it, which has a lot of strength. And one of the pleasures of working with them is that there's an openness. I almost want to say a kind of like childlike openness to if we're going to do this project together, and it's going to take us the better part of a decade or more, let's try and do something quite good. And if we're bringing together people with a lot of experience and a lot of intelligence, how can we deliver that in a sensible way? And I think the commercial point is that this isn't, for instance, the Bloomberg building in London also had very high ambitions, but it also had an unlimited budget. And I think if you want to make a difference, you want to see if there's a way of working within commercial constraints to deliver something by stripping back, by being intelligent about what you are implementing. I do think it was, I hope, a kind of meeting of minds, one that quite a number of people on the client side were architects. And I recall early on that we were first appointed, but we were at all the interviews with all the other sub-consultants. And the question at the end of the formal presentation was always, if you could do something even better, sort of this kind of open childlike question, what would you do? What would you really want to do? So it was a challenge, and that challenge, I think, was carried through with the team. Did it cost more? Yes. I think this is for a number of reasons. One, there was rising construction costs throughout this period, but it is, for a relatively small footprint tower, it's got quite complex construction. So where I think mostly you would look to rationalize and simplify the structure to a single construction type. Here we're using hybrid post-tension concrete with high GGBS content with steel and timber frame. The steel, and this was a post-contract stage change. We were the first building of this height where a proportion of the steel is repurposed steel. That it's steel sections that were taken out of other buildings and then tested and brought here. So I think there was a lot of that, yes, it did add cost, but it met the objective.
Look, thank you so much. It was a great lecture and a great technical lecture. But yeah, I have a question, but I think you kind of answered it. But it seems like you've used the project as a sort of test bed, as you say, you didn't rationalise this. It's not one thing. It's a whole bunch of things, which you've kind of enjoyed and been allowed to do. But it just seems like that's such a good thing to do. And I suppose it's, to what extent is any architectural project of a scale, an experiment or a prototype? I mean, are all buildings prototypes? I know this has been...
maybe more should be,
Right.
because I do think that it is quite incredible if we think of all the work that we do as architects. There is a huge amount of time and commitment that goes into doing even the most dreary buildings. And you'd think if that could be harnessed in a different way, then I think that might lead us somewhere. But I think there might be, and I do go, for instance, I was just in Canada where the construction industry is, for residential, for instance, in Toronto, is super standardized, and they don't do post-tension, they don't use low carbon concrete. Almost the design of the building is standardized, and architects are brought in to do decoration and take some responsibility for liability in what eventually comes there. And I think that's very wasteful for us as a profession, and it misses out all of the human qualities and the things that we expect for buildings that are in a city and should be giving back in many different ways.
Absolutely. Well, look, thank you. Thanks again. Thank you. Great lecture.